didn't I? Okay, well. Okay, picking up right where we left off. Keep going, Tim.
Set any denominators not equal to 0 and solve for x. Looking at this problem, what do we conclude about denominator cut points? In order to have denominator cut points, your original inequality must have... What's the big difference between this problem and the previous problem? There's something... This thing had denominator cut points. Is this problem going to have a denominator cut point? No, because there's no fraction or denominators. When I saw this problem, there are no fractions, so there are no DCPs. There are no denominator cut points.
Because there's no fraction.
Third step. I'm drawing my number line. I only have one cut point. It's a 4. And how did I say I was going to label it? Open circle. Step number 4, we're going to check intervals.
I think we should put the arrows on it.
Oh.
And the infinity.
Okay. To the left of 4, I'm going to check 0. Do you agree 0 is to the left of 4? To me, that's the easiest number to plug in, so I'm going to test 0. To the right of 4, what do y'all want to test? I'll let you choose. 13? I'm going to choose 5. I'm going to let you, it's like when I let friends choose where we go out to lunch, okay? If they choose the wrong place, they get to choose again. So, okay.
The part was I wanted to choose 5 at first, but I switched at the last second to 13.
Well, if you're going to choose something bigger, a number that's real easy to square is 10. I like to use 10 when 10 is in the interval. Just like I like to use 0 when 0 is in the interval. Plugging in 0, we get 0 squared, which is 0, minus 8 times 0 is 0, is less than negative 16. So 0 is less than negative 16. True or false?
True.
0 smaller than negative 16. False, so we cross it out. Plugging in 5. 5 squared is 25, minus 8 times 5 is 40, is less than negative 16. 25 minus 40, that's negative 15.
No. Yeah. Mm-hmm.
Negative 15 is smaller than negative 16. Be careful.
No.
False. This thing doesn't alternate. As a matter of fact, do we have anything shaded on that number line? No. The final answer would be no solution. But the important thing is, why did they not alternate? It's those even exponents that mess things up.
Remember, think it's the repeated factors. That's what I say.
The repeated factors, but that x minus 4 times x minus 4, isn't that the same thing as x minus 4 squared? Isn't x minus 4 times x minus 4 the same thing as x minus 4 squared?
Yeah.
So, once again, it doesn't matter what you plug in for x here. When you square it, you're always going to get what sort of a number? Positive. So, to me, it's the repeated factors, the fact that it can be rewritten as a square. Tony just looks, when you're factoring, if you get exactly the same thing inside both parentheses, then it's a good idea to check every interval.
But you don't need to factor it, like on number 5. That's how, when we looked at number 5, we never factored.
Do you see any even exponents there on number 5? Do you see any time you had to factor?
No.
So you were confident it was going to alternate. And I'm going to tell you a hint. It seems like my math lab doesn't have them rigged to have repeated factors. This is a perfect square trinomial, and that doesn't happen very often. So I'm telling you right now, be prepared. I think you'll be looking at situations like this, where it's, once you check one interval, you can assume an alternating pattern. The only way that won't happen is if it's something that's factorable and it's a perfect square. By that I mean you have the same thing inside both sets of parentheses.
I used to tell classes, when you do the factoring, if you wind up with the same thing in both sets, you better check. Okay? But I think for y'all's homework purposes, and for this course purposes, it'll alternate.
Okay?
Let's actually do a homework problem now.
Okay.
Number 3. On number 3, are we going to have any denominator cut points? Say no.
Let them look at the problem, okay? X times x minus 3 is less than or equal to 28. Okay.
See, they have the option of no solution.
There it is. You're right. That's what we would have had to done if that problem I made up had been a homework problem.
Okay, so x times x minus 3 is less than or equal to 28. Will there be any denominator cut points?
No,
because there's no fractions. You might make a note on the step 2. You only do that if there's fractions. If the original problem doesn't have any fractions, you skip step 2. So I'm finding the solution cut point by replacing the less than or equal to with just a plain old equal sign. And at first glance, you might not think this is a quadratic equation, but yes, it is. That's why I wanted to do problem number 3, because I'm not sure that there's been any that have popped up like this. If I distribute the x square, we'd have an x squared minus 3x. Now, does it look like a quadratic equation? Yeah. So to solve a quadratic equation, we have 2 methods that generally work, or to choose from: quadratic formula and factoring. Regardless of the method you want to use, you've got to have what number over here on one side? Not a 28. What do I need there? A 0. So let's move the 28 over. So even though it doesn't look like a quadratic equation at first, it sure is. X squared minus 3x minus 28 equals 0. So before I write out my 2 sets of parentheses, I'll write out the numbers that multiply together to give 28. There's 1 times 28, 2 times 14, and there's another pair that I'm missing. What's the third pair of numbers that multiply together to give 28? I'll get you going. 4.
Lifting 4 and 7.
Oh, okay. So 4 and 7. Now draw your 2 sets of parentheses. Oh, at least there's not a number in front of the x squared. Hopefully at this point you've realized that's the easier ones. If there's not a number in front of the x squared, you put an x and an x. Which pair of numbers do you think is going to work here? 4 and 7? Now that second sign, I put a little mark there. It was just my pen touched the paper, so that doesn't mean anything right now. The second sign is a minus. So what sort of numbers multiply together to give a negative 28? Well, a positive and a negative. How should I arrange those signs to get a negative 3x? I would put plus 4 and minus 7. Is that what I heard? And then if you want to FOIL it out, x to make sure, x squared, then a minus 7x and a plus 4x gives a minus 3x, then positive 4 times negative 7, negative 28. Now set each one of these factors to 0. And what are we getting at? X equals -4. And what's the other cut point here? X equals 7. We're going to need to label those on a number line. Do y'all remember? How do we decide? Are we going to put open or closed circles there? What do we look at? Okay, you look at this symbol, it's going to be a closed circle. Since there's an equal sign on the less than symbol, closed circle. Remember, it's the one that uses more ink. For solution cut points, you look at the symbol. For denominator cut points, it's always open, but for this one, do we have any denominator cut points? I think we've already decided no denominator cut points. Okay. Tim, you want to draw the number line and go from there? Okay, draw the number line. And, oh, which cut point goes right here? Which one's smaller? -4 and then the +7. And how do we say we label those? Okay, so they're closed circles. Hey, let's look back at the factoring stage. Yeah, did I have any repeated factors when I factored here? So it's going to alternate. That's one thing I didn't mention that I probably should. The only way you could get repeated factors in this factoring stage, that number there would have to be a perfect square. Remember the example I made up? 16. 16's a perfect square, 4 times 4. That's why that happened. 28. Is 28 a perfect square? So there's no way you can get the same thing inside both sets of parentheses. So we only have to check one interval. Step number 4, we're going to choose one interval. I usually ask myself, where does 0 lie? Is 0 between two negatives? Is it between a negative and a positive? Or is it between two positives? Which one of these intervals contains the number 0? Okay, so right here. Someone came up to you and said, you're in the two Mr. Precella's algebra class. Tell me something that you've learned. You can say 0 is always between a negative and a positive number, okay? And that is a very poor joke, okay? It's something that you know automatically. Plug it in 0, we get 0 times 0 minus 3 is -3. Is that less than or equal to 28? Sure not 0 times -3 is 0 is less than 28, true or false? I couldn't hear you? Yes. Yes, it's true? Yeah. So we shade. And what are we going to do with the other two intervals? Yeah. If we tested a -5 here, it would be false. If we tested something like an 8 or a 10 here, it'd be false. So, fifth and final step, express the shaded interval using interval notation. Oh, you're going to have to use a union symbol here? Say no. No, there's only one answer, one interval. Parentheses or brackets. Call it out as if you were typing it in. What would you type first? Bracket, I agree. The end point or cut point? -4, and then? Comma. If you don't put that comma, they're counting it wrong, and they won't tell you, hey, you're missing a comma. Right hand end point, cut point, 7, and what goes after the 7? Okay, good. It's a nice little process that you just follow those steps. You're going to get the answer even if you don't understand what you're doing. Where is it equal?
square is it undefined? Everywhere else it has to either be less than or greater than, and it can't change from being less than 28 to greater than 28 without either being equal to 28 or not being a number. An interval like this that starts and ends with a closed dot is called a closed interval. So this interval, our answer is the closed interval, -4 to 7.
Let me punch that in. Up here. Bracket, -4, comma, 7, bracket. Also check my answer.
Oh, wait. I want to point out something. You'll see these parentheses here. Even if you're using parentheses on your interval, I would not use this. This is set up assuming an ordered pair. So if you want parentheses, you use the parentheses key on your keyboard. Okay? Check answer. Okay.
Any questions? Six, the next one I want to do.
Okay.
Any questions? How do you know when to do the cut points? Notice at no time do the instructions ever say do cut points.
What do you see in your problem that makes you decide to use cut points?
Yeah, that inequality symbol. Perfectly said. If there's a less than or a greater than symbol, use the use the cut point method.
Oh, this one looks sort of messy.
Yeah. Number 6 is a messy one.
See?
And to make it matters worse, we have a z. Hopefully when you do it, it'll be a different variable, but that's not a 22 there on the right. That's a 2z.
Z divided by the binomial z minus 10 is greater than or equal to 2z. Hey, that previous problem we didn't have any denominator cut points.
What about this one? Are there going to be any denominator cut points?
Yes, because you see, there's that fraction, there's that denominator. But the first thing we'll do, let's find our solution cut point. Where does the left side equal the right side? So here's step number 1. We're finding solution cut points. Z over z minus 10 is equal to 2z. Those are z's, not 22's. And
we're now solving an equation. We know how to solve an equation that's written in the form fraction equals fraction.
Right, that 2z over 1, it's a fraction equals fraction, so you cross multiply.
I was going to have him tell me that. I was going to give him the hint, 2 words, C and M. Okay, so cross multiply.
2z times z minus 10. You have to distribute that 2z times the z minus 10. What are we going to get right here? So we have 2z times z.
I think I heard 2z squared.
Did I hear a 2z squared? Minus 2z times that minus 10. We have a minus 20z, I agree, equals there.
Z times 1, they all know it's just z. Anything times 1 is just anything. Or I guess you could write it 1z if you want.
I'm not going to.
And I wanted to do this problem in particular because we haven't actually solved a quadratic equation like this yet. What makes it different? Well, there's not a constant term on here. Okay? Everything has a variable. If I move this z over by subtracting 1z, we have 2z squared minus 21z equals 0. I'm treating this like it's a quadratic equation because it is a quadratic equation. There's a squared term, so it's a quadratic equation. And Tim, we haven't factored a problem like that in class yet, where there's not a constant, there's not some number. That's the easy stuff to factor. Okay, this was actually easier to factor. How do we factor it when there's not a constant? Well, do you remember factoring out a variable at some time in your life? There's a z in each one of these terms. If I did this, let me find a
You're reversing the distributive property.
Mm-hmm.
When there are three terms to factor, you reverse the FOIL property. Here you're reversing the distributive property with the two terms. Both terms have a z in common.
If I factored a z out of each one of these terms, what would be in these parentheses here? Z times, would it be a 2z? That's not a 22. I haven't written 22 anywhere in here. Minus what? 21? That's called factoring a variable out. Why are we doing that now rather than the trial and error? There's not a constant term. Okay? Any questions on this factoring? If you don't have one of those constant terms, a number without a variable, then you can just factor the variable out. Did we get two sets of parentheses with the same thing in it? No. So it's going to factor. It's going to alternate. But watch out. Set each factor to 0, including this z. This is the thing that students forget. There's a cut point. You take the z, set it to 0, then take the 2z minus 21, set it to 0, and what would I do now to solve for z? I would move the 21 over. Are y'all caught up? Are y'all following what I'm doing? Are there any questions? One more thing to do before to solve for z. What do I need to do?
Divide by 2.
Divide by 2. So 21 over 2. And that's finding the solution cut points. Let's decide between open and closed circles right now. How do we decide? Look up here. What's it going to be? Closed. Okay. So these two cut points, 0 and 21 over 2, will have closed circles. And earlier you said there'd be denominator cut points. How do we know there's a denominator cut point? Well, there's a denominator in the problem. So the denominator can't be 0. Z can't equal what number? 10? Mm-hmm. Open or closed. Denominator cut points you always label open circle. Because you're saying you can't have 10 over 0. If z were 10, you'd have 10 on top, 0 on the bottom. If you punch that into your calculator, you're going to get some sort of error message. So denominator cut points are always open circles. Now, step 3, we draw a number line. Okay. Now, notice something here in the factorization. Did we get repeated factors? Did we get the same thing as the factor? Do we have perfect squares up here? You've got that.
Oh, okay. And so y'all already know what's going to happen.
It's going to alternate.
Okay.
So we just need to test one interval.
Okay.
For your purposes, it'll always alternate.
Okay. So,
oh gosh, make sure you put these numbers in numerical order. We have 3 cut points. 0, 21 over 2, and 10.
So we have 0.
Which one's closest? Which one's the smallest number? Which one would be closer to negative infinity?
0. Now, 21 over 2, 21 halves, that's 10 and a half. And we have 10. Which one goes next? 10 or 10 and a half? 10, and then 21 halves. And you said 0 and 21 halves would be labeled how?
Closed circle.
Okay.
I'm thinking of that method, that think about it method. If you're thinking, oh wow, this is hard, let me tell you, thinking about it.
Don't make it easier.
Yeah.
It's easier to have a little recipe to follow. And what did we say about the denominator cut point?
Open.
Always open. Now we're ready to test. There's 1, 2, 3, 4 intervals, but we only have to test one.
My habit is to always see, can I test 0? But here we can't.
0 is a cut point, so you can't test 0. Well, what's a number close to 0 that would be easy to plug in?
5.
I think 1. I think 1, but you can use 5. It'd get the same thing. But right here, let's
You
see.
know what? Actually, his idea of using 5 is
Okay,
a good
we'll
one.
use
Let's
5.
test 5.
We're
Make a note
between
where it lies.
5 is between 0 and 10. So we're going to test 5 right here. That's going to give us, everywhere you see a Z, plug in 5. So you have 5 over 5 minus 10 is
-5.
-5. Well, I know that. I was going to let them say it. It's, shrink that down some so it'll all fit.
Shrink it down as it'll go.
Well, okay. Then, greater than or equal to 2 times 5 gives me 10. 5 divided by -5 is -1
Now you
is greater than or equal to 10.
So it's false.
So that's false here. What do we conclude? If we had tested -1 or -50 million here, what would we have it true? If we tested, that's 10, that's 10.5, so if we had tested 10.1 here, true or false? True. Now see what, by noticing that there's no repeated factors, so those intervals have to alternate. That's sure saving us a lot of work. What if we tested something over here to the right of 21 halves, like 11 or 11 million? True or false? False.
see, once you know this interval's false, then okay, it's alternating. So this one would have to be true, this one's true, false.
So fifth and final step, interval notation. Call it out the way you would if you were typing it in. What would you type first? We're looking at this interval here.
Open parentheses, negative infinity, comma, 0, close bracket.
Okay, I agree. Negative infinity always preceded with an open parenthesis, comma. The right-hand cut point is 0. It's shaded, so a closed bracket. Next, what would you type? U, that's the set union from the toolbar.
Open parentheses, 10, comma, 21 over 2, close bracket.
Okay. Open circle at 10, so parentheses 10, comma. 21 halves is the right-hand cut point. Closed circle, so a bracket. I agree. Any questions there?
Let me punch it in. And then, what was that? Parentheses.
Negative infinity.
Negative infinity.
Once again, there's no negative infinity hot button. You have to type the negative from the keyboard and then click the infinity. And you laugh at me saying that, but you'd be surprised how many emails I'll get. There's no negative infinity symbol. You got to type the negative yourself.
Look at what I'm about to do, and that's wrong. I'll see what I did. I put the square bracket down there beside the 2. It's going to say wrong. They don't know what's wrong, what you're doing. But here, when they give you a little hint, they have you finding the denominator cut points first, then the solution cut points. Test a point, shade. Now, what was wrong was I shouldn't have put that bracket there. Once I'm through, I'm going to move the right arrow. Once I punch in that 2. And now, Once I'm out of that denominator, I'll put my bracket. And now when I check it, it is right. So when we're solving this inequality, there's infinitely many solutions. What numbers are solutions? Any number between negative infinity and 0, including 0.
So any negative number
as
is a
well
solution.
as any number between 10 and 10 and a half, including 10 and a half, but not including 10. Try this some other way. Try to figure this out just by thinking your way through it. I assure you. Oh, this is a great little method.
Okay.
Now, we're about to review or do something that we did the last time. Do you remember how to solve an absolute value equation? Remember when we were going equal positive, equal negative? Does that sound familiar from the last time? Let's go ahead and write it down and we'll do it.
What's this number?
8. That's not a 17. It's absolute value of 7 minus 4x is greater than 16.
Absolute value inequalities are, I think they're taught in Math 371, but we were equations, but we reviewed them. We had an assignment on them last time on Thursday. We had an assignment over absolute value equations because we made the sweeping statement earlier that you can solve any inequality that has a solution by using the Cutpoint method. Where is it equal? Where is it undefined? Anywhere else it has to either be less than or greater than. So, since we've said you can solve inequalities, any inequalities you want to solve using the Cutpoint method, let's use the Cutpoint method to solve an absolute value inequality. This is an absolute value inequality. Oh, switch it over.
Oh, yeah, and you're trying to stick this in and ask, are there going to be any denominator cut points?
What do y'all think? Looking at this absolute value inequality, no fractions there in the problem, so no denominator cut points. But what's the first step of the cut point method? Replace the inequality with. That's why we practice solving absolute value equations on Thursday. Remember, we said you want that absolute value bars isolated before you do anything else. Well, I think the absolute value is already isolated, isn't it? But if it weren't, if there was a plus or a minus there, I'd move that term over. You still want the absolute value isolated. Well, we'll see. So, first step, replace the absolute value bars.
No, replace the inequality.
Replace the inequality with an equal to. There. And remember what we saw the last time. If you have an absolute value equaling a positive number, there are two numbers that have an absolute value of 16. This okay. For some reason, I always write the positive first, but either way, this stuff inside here has to reduce to negative 16 or positive 16 in order for the absolute value to be 16. So, you remember, we take the stuff inside there, 7 minus 4x, we'd set it equal to positive 16, 7 minus 4x, we'd set equal to negative 16.
So, when you do enough of these, you'll get to the point where you go from right here to just right here. Equal positive, equal negative is how you're going to be finding the solution cut points.
Okay, what do we need to do to get x by 7? Okay, minus 7. So we have negative 4x. 16 minus 7 is 9. Dividing both sides by negative 4, we get x equals negative 9 over 4 for my first solution cut point. Solving the second equation, what will I do?
Minus 7 on both sides.
Okay. So negative 4x equals negative 23, and then
Divide by 4 to make x equals negative 23 over 4.
now that I'm dividing by negative 4 to get, yeah. Of course, when you're right all the time, I don't say anything, but the one moment you make just the tiniest mistake, I pounce. Any future teachers? That's a good teaching tip from Timothy Precella, of course.
That's a bad
Teaching tip. But don't drop the negative. Negative divided by negative became a positive 23/4. And what did y'all say about denominator cut points? Oh, wait a minute. How are we going to label these things? Y'all didn't tell me that. We have two solution cut points here. How are we going to label them? Open or closed? What do we look at?
We look at the top thing, so it will be open.
Okay, there's no equality. There's no equality, so I agree. Open circles for those. And what did y'all say about denominator cut points in step 2?
There aren't any. There's no fractions. So skip those denominator cut points.
Well, I'll write out no denominator cut points. Step number 3, I got to draw my number line. We have 2 cut points. Which one's going to go first? Here?
Negative 9 over 4.
Okay.
Yeah, the negative is always to the right
That's
of
a
a
9
positive.
over 4. Here?
To the left of a positive. What am I saying?
23,
Negative is
4.
always to the
Okay.
left.
Open. Open.
Where does 0 lie?
Oh, by the way, did you get any repeated factors here? It looks to me like everything was linear. I didn't even see any x squares pop up.
So
No repeated factors.
the absolute value ones will always alternate. But we
The
did
linear
factor.
absolute value ones will always alternate. But so we only have to check one interval. What number do you think I'm going to use? What's my favorite number to plug in?
0.
0. Which interval contains 0? Interval 1, 2, or 3?
2.
Okay. So I'm going to test 0 right here. That's going to give me the absolute value of 7 minus, well, 4 times 0 is,
0.
so just a
absolute value of 7.
7 is greater than 16. The absolute value of 7 is greater than 16. False, so cross it out. So here, move it up. Here, what would we assume if we had tested something like negative 10 or negative 50 million?
Infinity.
It would have been true. What about this interval here? True or false? Shade or cross out?
True.
True again. Any questions on my logic there? Fifth and final step, interval notation. Let's do this first interval.
Those are infinity symbols I just wrote, not 8.
Here.
So
I'm waiting.
how do we write them interval notation there?
Open parentheses, negative infinity, comma, negative 9 over 4, close parentheses.
Union.
Open parentheses, 25 over 4, comma, infinity, close parentheses.
Is it 25? I got 23. 23 over 4?
3 over 4.
Okay. Good. There were no closed dots on the number line. That means we had no rectangular brackets, only parentheses. Any questions there?
If you look at, view an example, they have some little rules that they memorize for absolute value inequalities.
That only work for linear
Yeah.
inequalities.
Once you get to problem 11 and 12, the little rules just sort of fall apart. I'm always of the mind, why do you need something new? If you have a cut point method will work, why learn another method or memorize some rules just for a couple of different types of problems? So it's going to be a comma, -9/4, right arrow, another parentheses, union, parentheses, 23/4. Hit a right arrow rather than put in a comma down there.
You put that comma in the denominator, they're going to count it wrong, so be careful.
At the beginning, they let you do that and get away with it, which was actually a bad thing because eventually they'll stop and just start saying it's wrong. Let's see, did I copy it or punch it in right?
Mm-hmm.
Yeah. Check it this way. Any questions there?
So what happens if you have a negative number for like a denominator, and then on the bottom it's like x minus 5, and then it's greater than like a negative number?
I'm not sure I understand your question. Are you talking about an absolute value inequality?
No.
No? Show it to us after class. I'm not sure that.
Is it something like this? I mean, happened there we had a z minus 10.
I'm not sure. I'm not sure I understand your question. Is that's a good question. Is it like number 8?
No, number 6.
Number
That's
6?
Yes, but it's a negative number on top and a negative number on the other side.
Oh. Well, let's see. I guess the question is, like when we were plugging in the 5, we got a positive over.
Oh, like this?
Yes.
Oh, okay, I'll do that one real quickly.
I misunderstood. I thought you were talking about when you were testing.
Negative 4 over x minus 3 is greater than negative 1. It's going to work out easier than negative. Than
Let me ask
8.
you something. Are you going to have any closed circles on your number line?
Only time you get closed circles is if there's an equal sign, and there isn't, so everything's going to be open circles.
Are you going to have a denominator cut point?
Yes.
Yes, because you have a denominator.
I'm finding the solution cut points by writing it with an equal sign. And that -1/1, I think I'll just, that -1, I'm going to write it as -1/1. And cross multiply. Let's see, I'd have a -4 equals, this is going to be a little messy, -x plus 3. So I'm cross multiplying. And to solve this for x, here's what I'm going to do. I don't want that negative in front of the x. So I'm going to move that x over here. And then I have to do what? Move the 4 over there. Y'all follow what I'm doing with those arrows? I'm moving the x over so I don't have a negative x. I just have an x. And then I'm moving the 4 over. What's that going to give me? 3 plus 4. Is that a 7? So this is number 4. Is that the one that you were asking about?
Yes.
Is it working out similar to this one?
Yes.
Well, since there's not an equal sign, we're going to have an open circle there. Now, what about the denominator cut point? The denominator can't be 0. X can't be, well, for your case, 5. For mine, 3. Denominator cut points, if you look at step 2, always open circle. Oh, I'm not labeling the steps. So step 1, step 2, Now draw a number line and make sure you label those two numbers in numerical order. Which one goes closer to? Yeah, 3 is closer to negative infinity. 7 is closer to positive. Both of those had open circles. And did we get any repeated factors or even multiplicities, even exponents up here? We didn't even factor anything. So
all linear.
If there's nothing factoring, then it's going to alternate. I'll test 0. Where does 0 lie? Between 7 and infinity? Between 3 and 7? Between negative infinity and 3? 0 is always between a negative and a positive. So I'm going to say test 0. So I'm plugging 0 into the original problem. I have a negative 4 on top. 0 minus 3 is a negative 3. Is that bigger than negative 1? Well, negative divided by negative is positive. This would be a positive 1 1/3. A positive 1 1/3 is greater than a negative. True or false? Yeah, a positive is always bigger than a negative. So true. What am I going to do with the other two? False and true. So let me write the answer down in interval notation.
So would that mean that like a negative 2 over a negative 5 that gives you a positive 2/5?
Wait, a negative 2 over a positive 5, that would be over a negative 5, that's a positive 2/5. And a positive, it's still going to wind up positive, bigger than negative, true.
This number here doesn't really matter. As soon as you saw negative divided by negative is positive, a positive number is always bigger than a negative number.
So the interval notation, parentheses, negative infinity, comma 3, parentheses, union, parentheses, 7, comma, infinity, close parentheses. Any questions on that one? It worked out nice. It was only 2 cut points, no fractions as cut points. Okay. Any questions there? No. Jump to number 9. It's another absolute value. 6x plus 2. That's not a 16x plus 21. Minus, is that 15? Yeah. Is less than negative 1. When working with absolute values, there's one thing you have to always do first. Always, always, always isolate the absolute value bars. So before we do anything else, what am I going to do first here? So I'm adding 15. So we have absolute value of
Wait.
Oh.
Falling down on the job.
6x plus 2 is less than, let's see, if I add 15, what number am I going to have over on the right hand side? 14. Will there be any denominator cut points on this one? No, there's no fractions. So we're going to solve it as if it were an equation. How do you do that? How do you solve an absolute value equation? Well, you say equal positive, and then what? Equal negative?
So you're finding the solution cut points.
With the absolute value, in order to find those solution cut points, you go equal positive, equal negative. Now, let's see. I'll move the 2 over. So we have 6x equals what? 12. Divide both sides by 6. And we get x equals 2. What are we going to get over here when we do the negative 14? Let's see, I would move the 2 over.
It was 6x equals to negative 16.
Negative 14 minus 2 is negative 16. And then?
Divide by 6, so it's equal to x equals negative 16 over 6.
And 16 over 6, it doesn't go evenly, but I can reduce that by dividing both of those numbers by what? 2, would it be 8 over 3? Houston's going to always want you to simplify those fractions. I'm afraid if you left it as 16 over 6, it's going to count it wrong and not tell you what you did wrong. Something so minor. Okay,
open or closed?
Yeah, let's decide on open and closed circles.
Open because it's not less than or equal to less than.
Yep, so for the solution cut points, you look at the symbol, it's open. So that was finding the solution cut points. There's no fraction, so there's no denominator cut point. I'll draw my number line. Make sure you put these two numbers, they both have open circles. Make sure you're putting them in the correct numerical order. Which one is closer to negative infinity, a positive 2 or a negative 8/3?
Negative 8/3.
So, there and there. Is it going to alternate, or do we have to check every interval? There was nothing even to factor, okay? So there sure weren't any repeated factors. Now, okay, what number do I want to test?
0.
Yeah, where would 0 lie? Between two negatives? Between a negative and a positive? Or between two positives? Where's 0?
Negative and a positive.
Yeah, 0 is always between a negative and a positive. So I'm testing 0 by plugging it into, I think I'm going to use this one. If you want to use the first one before you move the 15, okay, but we could use just the one that has absolute value less than 14.
You know what I do? I always, once I've isolated the absolute value, I never look back at them.
Yeah, that's a good idea. I remember in previous classes, once I got this, I'd say, okay, mark that one out. We're through with that original problem. We're using only the one that has the absolute value by itself. So let me plug a 0 in. Six times 0 is 0. Plus 2 is 2.
Less than 4.
And the absolute value of 2 is 2. So 2
True.
less than 14, that is true. So that means shade here. And what about the others? Am I going to shade them or cross them out?
Cross them out.
Yeah.
So it would be Open parentheses.
Oh, wait a minute. Wait a
Oh,
minute.
wait.
Let me
Well,
get
I'm going to
there.
write it down.
Oh, okay.
Okay, keep going. Open parentheses.
Negative 8 over 3, comma 2, close parentheses.
Let me circle it. Parentheses, negative 8 over 3, comma 2.
Parentheses, negative 8 over 3. Get out of the denominator before you put the comma and the 2.
Any questions there? You're solving an absolute value inequality. You go equal positive, equal negative, provided you have it with absolute value bars isolated.
Okay, number 12.
You have to write really small to get this one done on one sheet of paper. That's always a good thing when you hear that.
I'll do this.
You want to do it? Write small.
I'll do my best, but I'm not a small writer.
I know.
Okay, number 12.
Don't worry, I'm not a small writer either.
Number 12. Number 11 and number 12 are both the exact same type of problem. Okay?
Let me ask you something before we go on. Look back at that previous problem that we just did. Okay, here.
Oh,
This thing here. Suppose instead of a less than, that it said greater than. Would any of this solution cut point work have changed? Instead of a less than, if it had been a greater than, would any of this stuff change?
no, it's still be.
Instead of the same cut points, well, when you tested 0, if that had said greater than, what would have happened here? Would we have shaded it? No, if that said greater than, you would have shaded, crossed out, shaded. But the cut point method works regardless of whether there's a less than or a greater than.
If you're a view example person,
Viewing an example on this, it's just mind-boggling the stupidity that's going on here.
they have these little rules. Just look at them. They're just going and going and going.
And if you think to yourself, oh, you're going to have to...
Look,
you
they
said,
have two different number lines.
when you're
Paul.
using the cut point method, how many number lines are you getting? How many number lines should you have drawn for each problem? Only one. They go through two different number lines.
I think they eventually get the third number line.
Yes, they do. And they just sort of pop it out. It's clear the person doing it was doing that old thinking about it
And oh wow.
and knew what the answer was going to be, but had no idea how to actually arrive
I
at
would
it.
suggest that for problems 11 and 12, do those now. Don't wait and go.
Go view an example because it
okay?
becomes a nightmare.
But if you don't, we have some of the media, the videos there are examples like 11 and 12. Okay, so before, I'll give you a warning. It's going to be a little messy.
Oh, it isn't that messy.
But,
it'll be okay.
yeah.
It's just so big, so long in the amount of work. But I'm going to write small so it won't look so bad. First of all, will we have a denominator cut point? No, I just like to notice that immediately. My number line, is it going to have an open circle or a closed circle? Am I going to have any brackets in the final answer?
Open circle.
There'll only be open circles because there's no equality. But here we go. Solution cut points. Solution cut point, you ask yourself, when is the inequality equal to 12? And notice the absolute value is already isolated. We don't have to move any terms around. The only way you're going to have an absolute value equaling positive 12 is for the stuff inside there to equal 12 or, so set it equal to 12, set it equal to negative 12.
Quadratic equations.
Minus 2.
Okay, we need it set equal to 0, so we'll minus the 12. That'll give us an x squared plus 4x. Negative 33 minus 12.
Minus 45.
I agree. It's going to give us a minus 45. equals 0. And then this is a simple trinomial. So we'll write our two sets of parentheses. X squared, 1 times 1, 1x times 1x, oh drat.
This thing, no matter how many times they regenerate these two problems, 11 and 12, they always work out to give you something that factors so nicely. A word of brilliance to the programmer that wrote this problem. What pair of numbers, 1 times 45, 3 times 15, or 5 times 9, do you think is going to work?
5 and 9,
Yeah.
negative 5, positive 9.
Okay, what about the sign? Y'all didn't say anything about the signs.
One side's negative, the other is positive.
Okay, so the last sign's a minus, so we're going to have one of each. 1 plus, 1 minus.
It's minus 5 and plus 9.
Minus 5 and plus 9. Play around with that to verify. Okay.
Oh, play around, it means FOIL it out. X squared.
X squared. Here's my little checking. First, outer, inner, last. Negative 5x plus 9x. Does that give us back that plus 4x? Yes, it does. So we set x plus 9 equal to 0. X minus 5 equal to 0. We're about to get two solution cut points. What are they? The first one, this one here, x plus 9 equals 0, gives me?
X equals negative 9.
Okay.
X equals positive 5.
Okay. So those are solution cut points. How are we going to label those?
Open or closed?
Okay, for solution cut points, you look at the original inequality. There's no equality, so I agree with open circles. And
If you're not, this is where, if you look at view and example, they draw a number line for some apparent reason.
you think, oh, I don't like factoring. You still have to factor if you view an example and do what they're doing, that nonsense. You still got to factor.
A good way to that I just found out of that can determine whether it's open or one like open circle stuff is that because it looks like an O already. It's O for open.
This? Oh, wow.
Just meaning like circle for like some people.
Oh.
Like some people might have a hard time determining like is this open, is this closed, like.
Oh,
Okay. Now, let's solve the second one. This is the bad part. Tony says this is so long. I don't think so. This is the whole thing right here. Look at where we factored in this step. Did we get the same factor, x plus 9, or x minus 5, x minus 5? No, so the same thing's going to happen over here. We're going to get two new numbers, but we'll be able to assume an alternating pattern. So there's only one correct first step to solve this quadratic equation. How about, what did you say? I couldn't hear you. Plus 12 on both sides, I agree. And remember when I say that, I'm not being, discreet or anything. I just didn't hear what you said, okay? I'm not trying to make you realize you've made a mistake. If I say I can't hear you, that just means I can't hear you, okay? Negative 33 plus 12. Okay.
Is this another one that's going to factor nicely?
Yes, it is.
Yeah, one side would be positive, the other side would be negative.
Okay, hold on. Let me do this. X squared, that's x times x. And you said there'll be 1 plus and 1 minus?
Yep.
21. 1 times 21 or 3 times 7. Those are the only possible.
Negative 3.
Positive 7 and negative 3, I agree. We've been going at this so long, I'm sure everything I'm saying is just hitting most of you in the face and bouncing on. So let's verify. Let's verify this factorization is correct. First, we're foiling it out. X times x.
X squared
Outer.
minus 3x.
Inner.
Plus 7x.
Okay.
Minus 21.
Okay. Negative 3x plus 7x. Does that give us a plus 4x? Yes, it does.
So it will be
Okay.
And on the other one, it will be x plus, or x equals 3.
Okay. Move the 7 over. That gave us x equals negative 7. Move the 3 over. That becomes x equals positive 3. These are still solution cut points. This is the most cut points we've had in a single problem, and they're all solution cut points, all open circles. So we have open circles on the 4 solution cut points. What did y'all say about denominator cut points?
There's no denominator.
No denominator cut points. I'll just make a note of that. Now I'm drawing my number line. There's negative infinity, there's positive infinity, and we have 1, 2, 3, 4.
The first will be negative 9, then negative 7, and 3, and 5.
Okay, I agree. The one closest to negative infinity, the smallest cut point, is negative 9. And then the negative 7, they have to go in numerical order, small to big. So then the positive 3 and the positive 5, they're all open. And I want to make a note of something. The test value, does that appear in your final answer? Look at this. Tony tested 0 here on the previous problem. Did he use a 0? Did he type a 0 in his final answer? The test values are not part of the final answer. And you'll notice we've been very consistent. Oh, we're testing 0. We don't put a little mark there and label 0. When you start doing that, invariably, those test values pop up incorrectly in answers. So the only numbers you should have labeled on the number line are the cut points themselves. To the left is a negative infinity, to the right is a positive. But do not label the test value. Otherwise, you'll wind up putting it on the, like this one here. He tested 0. Did he get 0? Does 0 appear in the final answer? No. The only thing your final answer can contain are negative infinities, infinities, and cut points. Okay? So back over here, where is it? Okay, you want to test 0. Which interval contains 0? Interval 1, 2, 3, 4, 5.
Number 3.
I agree. It's here between 0 is between a negative and a positive. Did y'all follow our logic where 0 appears? But you could test 10. You could test 10 million if you wanted to. But I think 0 is the easiest number to test.
But it can be tricky.
So then it would be 0 squared plus 4 times 0 minus 33, which would just be negative 33.
Okay, so you're plugging in 0. That's 0. And then 4 times 0 plus 0. And then minus 33.
So it's just 33 is greater than 12, which is wrong.
Oh, Tim, you're
What?
out of room.
Oh, okay, I'm moving up now, here. So 0 plus 0 minus 33 is what? What do we have inside?
33 is greater than
12. True or false? Be careful. I think it's true. Remember, you have to take the absolute value. The absolute value of negative 33 becomes a positive 33.
That's why I said a while ago it was tricky. You've got to take that absolute value first.
Before you decide true or false.
On the other one, like, I think it was already just absolute value of 2, which was 2. But here, you make sure you take the absolute value first. Don't look at the negative 33 greater than 12. Look at the positive 33 greater than 12.
Any questions there on our logic?
So is that going to be true or false? Are you shading or what?
True. So we're shading here. No repeated factors. No even multiplicities. I mean like x plus 7 times x plus 7 or x plus 7 squared. So we know the signs have to alternate. So here, shade or cross out.
Cross out.
This one.
shade.
Okay, what about between 3 and 5? Cross out. Y'all understand what I mean by alternating? You're not having cross out beside one another, or shade, shade. What about 5 to infinity? Shade. Oh, goodness.
So then the answer would be open parentheses, negative infinity, comma, negative 9, close parentheses, u, open parentheses, negative 7, comma, 3, close parentheses, u, open parentheses, 5, comma, infinity, close parentheses.
Correct, and very well said. Okay, hold on. I'm going to do something. Switch it back to the Word. I've lifted it up, so it's going to, I'm hoping it'll show more. Okay, is it going to be, oh, there it is. Okay, so you set it equal. The long part is the factoring. Well, that nonsense they do under view and example, oh, I bet you Pearson doesn't like me calling it nonsense. Well, okay, I forgot we were being recorded. Oops. Sorry about that. But you still have to factor. Okay, you still have to do the long part of factoring. Once you've done all the factoring, draw your number line. No repeated factors. It alternates very nicely. Remember to take the absolute value. This is where the students make the mistake. They say negative 33 is greater than 12. Cross it out, and then they have every interval wrong then. And this one says greater than 12. If it had said less than 12, you'd still do the same thing, except at the end, the shaded and crossed out intervals would be reversed. But the cut point method takes care of this, whether it's whether it's greater than or less than. Oh, look at this. I didn't remember this.
Yeah, now they want you to choose the number line.
Oh, wait a minute. Let's look at switch back to mine, what I have here. Okay. Notice they're not putting the open circles, they're putting parentheses in place of that. I don't like doing that because I don't like it because you don't know whether you're going to face the parenthesis left or right. But either way, in place of putting an open parenthesis, instead of an open circle,
method, they come up with the answer before drawing the number line on view and example. Okay, well, before drawing the final number line. But for cut point method, you should only draw one number line and test like that. Okay? And this is called solving an absolute value inequality. You can impress people with
solving a quadratic
absolute value inequality. You can impress people with this. By that I mean you can go to tutors, and a lot of tutors won't know how to do this. Okay? This type of problem using the cut point method is easily done. Well, if you call this easily done. Otherwise, But we're about out of time now, so I guess we'll see y'all on Thursday. All right, Thursday. Let's stop the recording.